Hey everybody, welcome to Mondays with Mike. I'm using a new gadget today to try to record this. I mean, look, I'm in this bubble thing. It's kind of cool. It's called Loom. So it was a Google extension, a Chrome extension that I downloaded in a program. It's called Loom, Loom. Not, I'm trying it for the first time, so you might want to try it too. I think it's kind of cool. So anyway, today, what I wanted to do was talk about this very interesting set of satellites that were going to be launched this weekend, what happened to them, why it's not the end of the world, and why I do think it's a pretty awesome thing that, honestly, I got to be honest with you, I didn't know about. So what we're looking at right now is an update from NASA. So what happened was, well, let me go here to Fox Weather. So over the weekend, yesterday, so you know how NASA contracts out their rockets. So we don't use NASA government rockets anymore. You know, we have SpaceX and we have, there's this company, Astra, and some others. And Astra was launching some new weather satellites into space yesterday, or at least was attempting to. And unfortunately, as this headline says, NASA's Earth-observing TROPICS satellites, and TROPICS stands for something, presumably lost as Astra rocket fails to make orbit. This was really a shame. There was the rocket was a multi-stage rocket. So the first one, it's a 45-foot rocket. So the first one, it took off just fine, looked good. And then when it hit stage two, when the bottom part breaks off and stage two is supposed to start, it failed. So the satellites are presumed lost, and so that was a fail. Let's see, at 1:40 p.m. Cape Canaveral time. This is from Cape Canaveral, Florida. So, but what was interesting was that I had not been familiar with what these satellites were all about. So ordinarily, what we have are what we use on a day-to-day basis, to show you our hurricane loops and things like that. What we use is called a geostationary satellite. And a geostationary satellite is one that is very far into the atmosphere. Out of the atmosphere, very far into space. And it is about 22,000 miles above the surface of the Earth. So give or take about 10% of the way from here to the moon. Well, that's pretty far, right? I mean, imagine taking a picture from that far away. I mean, you'd have to have a pretty good zoom lens, right, to be 22,000 miles away and see anything with any clarity. Well, they have to be that far away because they are what's called geostationary. So the goal with a geostationary satellite is to have it over the exact same part of the planet all the time. So that way you can see, like what we're looping in the background here. The camera's not moving around all over the place, right? It's taking a series of pictures that we're able to view as a movie, and it's not moving around. So the way that's accomplished is to launch a satellite. And by the way, these are very large satellites. These aren't little. These are like the size of a car, and they cost hundreds of millions of dollars. So you launch those things into space at a very, very high altitude orbit. And it turns out that they place them at an orbit where they orbit the Earth once every 24 hours. Well, the Earth also spins once every 24 hours. And so you want that to be completely in sync or synchronous. And so that's what we have, geostationary or geosynchronous orbit. Those are called the GOES satellites. And despite the fact that they're very far away, they give us this amazing resolution. I mean, the loop that you see running in the background is what we would call the IR channel or infrared. And it's measuring temperatures. So the bright colors here are cold temperatures. The reason we want to measure cold temperatures is because that's the top of the atmosphere. The taller the cloud is, the colder it is. And so therefore, it allows us to see tall clouds. Anyway, these things have their pros and cons. The great thing about the GOES satellite is that it is geosynchronous. The bad thing about it is that it's 22,000 miles away. And so there's only so much resolution you can get. Now, in order to solve that problem, there are satellites called polar orbiting satellites. And polar orbiters are lower. They're about 500 to 700 miles above the Earth. And they go pole to pole like this. And it's kind of neat because, well, let me see if I could pull up maybe like a diagram. Let's see. Polar orbiting satellite. GIF. Okay. So here's a GIF. I love GIFs. So you see this GIF there. So the way a polar orbiter works is it goes around the Earth about 12 times a day. I think 12 times or 13 times a day. So it goes around pretty frequently. But what they do is they put it sun synchronous. What does that mean? Well, they set it up so that the sun is always behind the satellite, so that as it goes around, it stays the same and the Earth orbits beneath it. Okay, isn't that kind of cool? So it goes like this, north to south, and the Earth spins so that it makes a pass here, right? Then the Earth spins, while it's going around, and it makes another pass here. The Earth spins, so what you end up with are these strips of really high resolution data. And since it's really high res, those types of satellites are used to detect things like forest fires. They can measure real specific things like deforestation, which parts, are areas of vegetation spreading or shrinking, really close up stuff. And so those are great. And you could use them to study the tropics also. But the thing is, you're only going to get one view you're going to get like 2 views a day. And they're going to be these strips, which is okay, but it's not ideal. So anyway, what NASA came up with here were a series of cube satellites. Okay. And they're called TROPICS. And I got to tell you what TROPICS stands for, because in the world of meteorology, scientists love acronyms. Oh my gosh, they love acronyms. Let me see what it stands for here. I mean, they're like addicted to acronyms. Okay, you ready? TROPICS. It stands for Time-Resolved Observations of Precipitation, Structure, and Storm Intensity with a Constellation of Small Sats. TROPICS. It's ridiculous, but it's kind of cool, I suppose. They love acronyms. Anyway, the cool thing is that these things are small. I mean, really small. They are diminutive in size. I was going to try to find you a good picture of one, but they're approximately the size of a slice of bread. Not a slice of bread, a loaf of bread. That would be small if they're the size of a slice of bread. A loaf of bread. They're that big, these satellites. But think about it like a GoPro camera, right? I mean, GoPro cameras like that big, and you get these beautiful super HD images. So you could pack a lot of technology into a small package. And anyway, these things are either in the shape of a cube, or sometimes they're kind of elongated, but they weigh like literally 5 or 10 pounds. They're small. So this particular mission, I think, the one that failed over the weekend, I believe was launching 2 of them. The goal is for a total of 6 of them. And the cool thing about it is they're going to be whizzing around the Earth several times a day, because they're only going to orbit at an altitude of about 400 miles, give or take. I forgot if it's 400, 450, something like that. So these things are going to be just whizzing around the Earth, which, like I told you, is kind of bad because you just get these little strips of data. But if you have 6 of them, and they're all kind of covering different areas at different times, and you get a really good computer to download all that data and you put it together. And so that way you can get much more frequent high-resolution updates from developing hurricanes. So let's say there was a big hurricane out there, and you had this imagery like this, and we're just getting this broad view. Well, now you could take these little cube, or they're called nano satellites, and you could get to pass over these things several times a day and get these real super high resolution, not just visual images, but I think they do like microwave measurements and things. Because anything that has heat, anything that has a temperature emits radiation. Infrared radiation, light radiation, microwave radiation, they all emit radiation. So anyway, these things can measure that. And anyway, but the sad news is that the rocket broke. It was unsuccessful, and so they lost 2 of these satellites. I guess the good news is they are not, as I've read, they are not expensive satellites. Obviously, the research that goes into them is priceless, right? But the actual apparatus themselves are not that expensive. So that's good. In other words, it's not like losing a $200 million satellite. These things cost like, I don't know, 20 grand or something. I mean, it's a lot, but not by government standards. It's not a lot. So anyway, that's what happened this weekend. Let's see. The satellites were built by an outfit called Blue Canyon Technologies in Boulder, Colorado. And they were launched from Florida. There were 6 of them. And now there are 4 of them. Poor little satellite. Yeah, they call it, what is that? No, I don't want that commercial. So anyway, a lot of this, it looks like the MIT Lincoln Laboratory, was involved in developing them. They also have what's called a microwave radiometer, which means it measures microwaves, and it spins around really fast. I mean, this thing is crazy. I mean, to think, how would you even begin to engineer something like that, make sure it works, launch it into space, get it to download, to download data? The whole thing is mind-blowing. So the fact that we lost 2 of them in a rocket malfunction is, not that huge of a deal. What I also found out is that this is not a new idea at all, these nano satellites. There are more than 1,000 of them in orbit right now. Some of them are as small as 4 inches. I mean, think about like what a spy agency would do with that. A little satellite that big? It's crazy. So they're in low Earth orbit, and they could take a bunch of images, and how are you ever going to see them? Like if Russia or whatever was spying on us, how would we ever know? I mean, the thing is 4 inches by 4 inches. It's like a Rubik's Cube. So that's that. So we'll see if the next launches go okay. We shall find out. But once these things are up and running, it's going to be pretty cool. It's going to be pretty awesome. We'll get some new data. Let's see. The other thing I wanted to tell you about, well, there were 2 other things. One was possible tropical development. Could there be tropical development? Maybe. Let me go ahead and zoom in here on Western Atlantic. And this is the area we're going to watch right there next to my head. There's about a 20% chance of development with that one. It's not necessarily coming straight at us. Our GFS models is always still continuing to do what it's done all season long, which is it goes totally ballistic. When it's a 16-day model, it goes totally loco after like day 12. It's done it all year. It did it since early May. It's been showing giant hurricanes showing up on day 13, day 14. And I will never share those pictures with you because it's dumb to do that. Because if you wait for the next model run and the next model run, it'll show something like, in other words, today it will show it 14 days from now. Tomorrow, it will also show it 14 days from tomorrow. The next day, it'll show it 14 days. So you see what I'm saying? So the model is just kind of blowing up at the end. It's not consistent. It's not making any sense. So anyway, don't pay attention to those. We'll let you know if there's anything to worry about. And then, of course, the other deal, and by the way, I'm on this one of my favorite websites here, Tropical Tidbits. It's free. You can support it. You can put something in the tip jar if you'd like. But I did want to show you a little bit about the heat wave. Let's see. Can I move my... Ooh, look, I'm going to move. I just moved myself. Let's see. I'm going to put on, let's see, upper dynamics. And we are going to look at 500 millibar height anomaly. Well, what is that? Well, it's a particular portion of the atmosphere that's about 18,000 miles above the ground. It's what we're looking for troughs and ridges and, ups and downs, in the jet stream, whether or not we're going to get caught under a heat dome kind of a thing. And so when we look at the situation today, you'll see that this pinkest part or like darkest part here is over Missouri. And that's where they have heat advisories. It's going to be like a heat index of like 110, 112 up in St. Louis today. There's excessive heat warnings. And then if you loop this into the future, you'll notice that blue blob, which is colder air, is going to be moving across the Rocky Mountains. But we stay under the influence of this area of high pressure, really for as long as I can see. Now, once you get to like this, let's see, right there. So let's see, this is Wednesday, Thursday the 16th. If the high is located to your north, you can sometimes get some rain that sneaks under the bottom of it. South Texas, maybe. So that's our one chance really for seeing some rain. The late part of this week, maybe some thunderstorms. But in general, this heat wave is going to reach from the Gulf Coast to the Great Lakes, eventually up into Canada, where it's just going to be a big, big deal. In fact, I can click on something here, which we would call, let's see, the temperature anomaly. So is the temperature above or below normal? And you'll see here that even into this upcoming weekend, you will see red everywhere from the Carolinas to Texas and all the way up to Western Canada. And where you do see blue, like if I click ahead one, and you see those blue blobs over Houston, that's rain. So that's Friday. So we'll see. We'll hold out hope for that. But in the meantime, you're going to see a lot of red here on this anomaly map, which just means the heat wave continues. So anyway, so that's what I wanted to talk about this week. Nano satellites not making it to space this week. Good luck in the future. It's going to be amazing technology. The heat wave continues for Houston. Oh, before I go, also Saharan dust. The Saharan dust is going to be an issue for us. Not a huge issue, but it'll make the sky hazy and may irritate those with allergies here over the next few days. And we'll keep an eye out for any hurricanes forming in the Gulf. And other than that, we are done for today's Mondays with Mike. So I want to thank you so much for joining me. And please leave a like and a comment. And I always look forward to that. And we will see you next week.